Hello guys, so in this video we are going to use another important program, that is a Leetcode question, and it's a hard question, that is odd even jumps. This question has been asked in Google interview many times, and most of the folks pinged me about this question that they do not understand in my old videos. So I plan to create a new video so you can easily understand, and I have segregated these questions that you can say to understand easily. So let's continue. If you have any doubts, please ping me in the comment box. Okay, so I'll keep on improving the videos for you, and that's all. So let's continue. So we are going to see the odd and even jumps, right? So in this question, so we have given an array, as you can see here, and from the starting index you can make a series of jumps, either first, third and fifth jumps in the series are called odd numbered jumps, and if you are making second, fourth and sixth jumps in the series are called even number jumps, that we will explain further. So keep listening. Note that the jumps are numbered, not the indices. Make sure that you are not confused with the jumps and the you can say order, right? So which order we are going, either odd or even jumps, and those are not the indices. So most of the students doing this problem, they are considering that odd and even jumps are same. So don't make the confusion in your mind. Make sure you understand everything, right? So you will understand the solution properly. So I'm saying there is a jumps are given in the odd fashion and the even fashion, right? So these jumps are not the indices, right? So you may jump from index I to index j, right, where I is always less than j, right? So it is saying during the odd number jumps, right? So we have given what for jump 1, 3 and 5 and so on. So you jump the index j from I to j, right, where element at I is always less than equal to j, right? Means when we are going with the odd number jumps, like from 1, 3, 5, 7, like that, in that case we will have the current element will be always smaller than all other elements where we are going to jump, right? The smallest possible number, you can say. Next we have even number jumps, as you can see here, right? So when we are making jump 2, 4 and 6 and so on, that case the current element will be always bigger than the jump elements, right? So now we can see the largest possible value we have to find, and so we can say if there are multiple such indices, so you can jump the smallest one. Okay, so you have to understand these things, right? It may be in the case for the some indices I, there are no legal jumps, so we will see there also. So a starting index is good index. If the starting from the index you can reach the end of the array, means if you are at index 0 and you will reach at the n minus 1 index, right? It means that is a good index, right? So we have to find those indices, number of times how many jumps we can make, and we have to find the number of times that we can do that to reach the last index. Okay, so let's see the first example what we have here. So example first, we have given 10, 13, 12, 14, 15 in the array. These are the elements you can see here, and we have to make a output 2. So how the output 2 is coming is very important to understand, right? So let's see. So as I told you, the jumps we have given the series 1, 2, 3, 4, 5 and so on, where 1, 3, 5, 7, like that we have odd number jumps. And if you talk about 2, 4 and 6 and so on, it is even number jumps, right? I'm repeating so many times because this is important. Okay, let's continue. When we are talking about the odd number jumps, right, so you can see the element at I is always less than element at j. You got my point? Means element at I means current element is always less than the current element. The always less than the current element. So we can say the elements are 1, 3 and 5. Elements are current elements are always less than smallest one, you can say, in the odd number jumps. And the jumps ordered are 1, 3 and 5 and so on. If you talk about the even number jumps, in that case current element is always bigger than the comparing that we are going to make the jump is always greater than, right? The current element is always greater than or largest, you can say, right? So even number and odd number is completely opposite, right? Where the odd number will have the current element is smallest one and the even number having the largest one. Got my point? Now understand, when we are going to make the first jump, right? So first jump, we can start with the first jump is what? Odd number, right? So we have to find the smallest element between the elements, right? So when we are making the first element, we can make our first jump from I equal to what? If we'll start from 0, let's suppose, right here. So when we are making the jump from I equal to 0, we can make our first jump I equal to 2, right? As you can see in the here, right? We can make jump here I equal to 2. Why? Because array at 2, that is 12, right? The 12 is the smallest element between all these three, right? Means 13, 12, 14 and 15. So among all these, right, 12 is the smallest one, and so we can say 12 is the greater than or equal to 10. Am I right? So for the even case, we can say we can make, right? So either we will make odd or even jumps, right? But in this case, when we are starting from the 0, means the first jump we will make. So in this case, we do not have any the smallest element, right? But when we are going with the index 1, means we are making even jumps, right? So from here, right, we can say we can make a jump to 12, right? And so this is possible, right? So in this case, what we can say, we have a smallest element which is less than 12 is the greater than or equal to 10, right? We can say, and so we can have our element. So in the even jumps, we will reach to 12, and then we do not have any such element that we can say it's greater than or equal to, right? Means after 12, there is no such element which is less than or equal to or greater than equal to, we can say, right? So we will going to make another you can say jump. We will stop there. Now we are going to see the index I equal to 1 and I equal to 2. So we can make our first jump to 3 here, and so we will reach to 3, right? You can see here, right? So first we'll start from 0 to 12, then 13 to 14, like that, and 14 to 15, right? Because we can make that jumps, right? So finally you will not reach till directly from these indexes, but we have what? We have already 13, reached to 13. So from 13 to 14 we can make, right? And 15 itself we can make. You can see here, right? So 13 to 14 we can make, and another is 15 itself, right? So we have two different indices, that I equal to 13 to 14, 13 and 14, where we can reach the end of the you can say jumps, right? Number of jumps. So as you can say, the first we have to make 0 to 2, because 12 is the smallest element between 13, 12, 14 and 15, right? And 12 is a greater than equal to 10. In that case, we can make a jump, but we cannot make further jump because there is no smallest element, right? So when we are going with the I equal to 1 and I equal to 2, we can make one jump 2 to 3, because there is a possibility, right? And further we cannot do that the same. Now when we are going to I equal to 3, we can make from 3 to 4, because that is possible, right? So only 3 to 4 we can make one jump, and this is 3 to 4 and 3 to 4, and another is 4 itself, right? We can make to 4 itself, so we can have two number of you can say indices jumps, right? And so the output was coming 2. I hope you understand this example. Let's understand the solution so you will have a clarity. Okay, let's talk about the solutions, right? What we are talking about. So here what we have odd and even jumps we have given, and in this case we are already seen in the example. This is the array, right? So the input array here is 10, 13, 12, 14 and 15, right? So when we are making jumps, right, so if there is no element, right, in that case what we should do? So we will return one here, right? So this is your base case that we have to consider. As a programmer, we have to consider the edge cases, right? So let's suppose there is no element, then what should be the answer? So we'll return 1. You can ask this quality question to the interviewer also, right, from the interviewer. So if the array length is equal to 1, in that case we have to return what? We have to return 1, right? And then we will create what? The jumps. We will create arrays. So I will create odd jumps and even jumps. 2 array we will create. So initially you can see here, right, we have jumps. So all the values we have as a false, and we'll keep updating to true, right? While when we will reach the element to the, from where we will make a jump and will reach to the last elements. So as I told you, from 15th element means 4th index, we can make one to itself, right? Means last index, if we consider the last index, so we can say we can reach to the last one, right, itself. So we have to make that element as a, you can say, true, right? So last element, last index we can say, so last index is always a good index. So we will mark this last index as a good index. You can see here, right? So we have marked as a good index here. Okay, so in the odd and even, both we will mark as a true. Okay, when we talk about how we are going to store the element, right, to store the next jumps indices for odd and even, we will create a map, hash map. You can say, sorry, tree map. Why we are going to use the tree map? Because we will come back to here, and why we are going to do that I will explain you again. Okay, so why we are going to use tree map in the solution? Because the tree map is used because it provides several key features and that are essential for the solving this problem actually. Okay, so let's understand why. So first of all, the tree map is itself a self-balancing binary tree, binary search tree, you can say, right, like a red black tree. That means it maintains its element in the sorted order, right? If you are aware with the red black tree, what red black tree is doing, it maintains its element in the sorted order, right? So it will become balanced, right? So you can say just a tree map is a self-balancing binary search tree. So this order is a crucial because let's suppose for odd jumps, you need to find the smallest element that is greater than or equal to the current element, right? So for example, if you're going with the odd jump, right, what you need to find the largest element. So in that case means you can say largest element that is less than or equal to the current element, right? So for the odd jumps, we need the smallest element, we have to find the smallest element, and for the odd jump, for the even jumps, we need the largest element, right? So that we have to maintain a sorted order, right? That is why tree map directly supports operations like retrievals, like selling key and floor key that we will use here, right? Because tree map directly support these operations to find the smallest one and the largest one. So to find the smallest one, we have selling key, and when we are talking about the largest element in Java, right, so we have floor key. So that is why we will use this order. Okay, tree map we will use, right? And our you can say in the complexity side, so it is also efficient for lookup, right? Why? The tree provides algorithm like time complexity O log n, right, for insertion, deletions, lookups, right? We can say when we are we have the elements, we want to find the element, we want to do insertion, or we want to do lookups, right? In that case, it will give you O log n, right? So this efficiency is critical for handling the large array elements within the some time frame, we can say. But other data structure like HasMap do not maintain such an order, right? Sorting order. So you will lose this feature, like to find the largest and the largest or smallest, you can say, element, smallest or largest key, right? Because in this program we need to find that. Okay, I hope you understand these things, right? Now we are talking about the has tree map, right? So we understood why we are going to use the tree map, right? So as I told you, the last element itself is a very important, because from the last index, right, we can always have a good index, because we can reach from we can reach to the last index. So last index is a good index. That is why we are saying the last index is always a good index. So we have to put into the tree map also, right? How? You can see here. So map, we will do map dot put a last element, we will put the element and its index, right? So when we will put the index, so the tree map will look like here, 15 and 4, right? Now let's talk about initially when we have set the last index, because this is last index is always good index, and that is why we will make last index as a good index. And so the good index count is, we will start with the 1. When we will find the another index that is a good index, right? So in this case this will become like 14 and 15, right? For the 14 and to the 15 it will become good index, right? In that case what will happen, this will also become true. So we will count this one, and this is already counted, so we will return 2 value, right? So we'll start with the for loop, line number 16 I am talking about. We'll start with the I equal to n minus 2, and then I is greater than or equal to 0 and I minus minus. Why we are taking n minus 2? Because n minus 1 we have already counted, so we'll start with the n minus 2. Last element we have already put, so we'll go with second last element, right? And the second last element is at what? 3. So index will start from index I equal to 3, then 2, then 1, and then 0, right? So this for loop will start like this, 3, 2, 1, 0, right? Because index, what we have in index for the array here, you can see here, right? We have index 0 to 4. So the starting index will become what? 3 to 0. Since the last index we have already put on the map. Got my point? Let's talk about line number 18. So we have to find the next odd jumps indexes, right? So if you'll talk about the array element, what we have, array element at I. So array element at I means at 3, index 3 we have 14, array index at 2 we have 12, and array index 1 we have 13, and 0 we have 10, right? Now when we are going to find the selling value, map dot selling value, so in the map what we have currently here, we have 15. So selling value you will get 15. Then we will get the odd index. Odd index is nothing but 15 here. So we will find odd index not null. So when odd index is not null, we will do what? Even jumps at 15. That will come what? Some element will come, and that is true or false. It will come true, right? So we will add other elements also here, similar to that, right? So we will find odd index, which is 15 here, as you can see, and then even jumps at 15 we will add some element here, right? So we will have odd jumps at I, 4, 3, 2, 1, like that. So initially on the map we will have 15, then 14, then 14, then 12, right? We will have like this, because we are getting the selling value. For the selling value, for 12 we will have 14, for 13 we have 14, for 10 we have 12. So you understand the selling value, right? Selling value means next to the element, you can say, top element, you can say. And if you want to floor value, it's lower value, we can say, right? Smallest and biggest. right, like that. But in the smallest we have to find the smallest one, but for the largest one we have to check the smallest largest one, not the biggest largest, right? Like 15 we cannot take as a 15, right? So for 14 we have the largest as a 15, but for 12 we have 13, right? 14 for 13 we have 14, for 10 we have 12. You understand? Like that we have to find. That is why we are using ceiling key, right? I hope you understand. Pause this video, try to understand, then you will understand. That is why I have written all these things here, so you will understand this, right? Make a note of this video. Next, find the even number jumps. How we are going to make? Let's suppose, so we have our odd jumps here, so we will update odd jumps. Like we will initially the last element we have already done, right? So from 14 to 15 when we are going to do, we will get what? The true element, right? It will become true and rest of the will become false. So in this case, let's suppose this will become true. You got my point? This will become true. So now two true is here, one was already was there, another we have made here true, right? So we will have odd jumps like this. This is our odd jumps, let's suppose, and we have maintained. Now talk about the even jumps. How we are going to find? For the even jumps, right, we have to find first all the array elements. So array at I we have already talked about. For the index 3, 2, 1 and 0 we have 14, 12, 13 and 0 as we have talked about here, right? So array at this. Now we have to find the floor key. When we do map.floor key at these elements, you will get even index, right? So even index will become what? If you'll check in the map.floor key, only you will get 12 value here, right? And rest of something is null initially, right? So at index 3 you don't have element, 2, 1, 0 we will have only one element as 12. So even number we will get only one time, right? Now we will make map.get even map.get at even index, right? So in this case, what index you will get here? 2, right? So at 2 we will make odd jumps at 2 is nothing but false, right? And we will set this value on the even jumps, right? So in the even jumps everything is false, 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 right? So all are false. Initially we have already marked false, 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 like this. Only the last one is last index is false, right? So we'll leave that is not important. Now coming back to the odd jumps at I is true, odd jumps at I is true, then I is a good index, right? So you can see at index here we will get 1, because from here to here we can make a 1 jump, and this will make itself a 1 jump, right? So it's for the itself we have already marked as a 1, but when odd jumps at I is true, so when we will get the true? The at I equal to 3, right? When I equal to 3, here you can see I equal to 3 we have true, right? So when it is true we will make good count index plus plus and we will return this as a true, sorry, as a value 2, okay? But we have to also update the map, right? Because we have to find the largest and smallest, right? From here only, right? So on the map we will do map.put array element I equal to 2, array element and its index, right? So how array index and element will get stored, right? It is actually this is very important, right? So when, let's suppose, when array element I equal to 3, here let's suppose I'm talking about here, let's put here. So I equal to 3, so what map value will come, right? We see I equal to 4, then we have already put what here? I element we have already put what? 4, right? When this is 3, when it is I equal to 3, what element will get stored here? Think, because I equal to 3, so add 3, what we have? See here 10, 13, 12, right? Then we have 14, right? And so array element, array at I, we will get what? focus, array element at I equal to 3, we will get 14 here, right? So you will get 14. So we have kept, let's suppose I'll keep at a 14 here. Okay, then array element at 2, what you will get? 12. So we will add 12. Then array element at 1, what you will add? 13. We will add 13. And then what we will add? Array at 0 is 10. So all these three we have to put, right? So in the tree map will make 10 0 in the sorted order, 12 2, 13 1, and then 15 4. You got my point? So this will become like this, and 14 3, one is left, 14 3, right? And is not here in the list. Okay, like that we will have the element and its index in this tree map, you can say, right? And we have already talked why we have used the tree map, because tree map is a self-balancing binary search tree, you can say, and it is similar to red black tree, means it will maintain its element in the sorted order, because we have to find the odd jumps and even jumps element. Like for example, like for odd jumps we need to find the smallest element that is greater than or equal to the current element, right? And for odd jumps we need to find the largest element that is less than or equal to the current element, right? So I hope you like this video, guys, and if you have any doubt in the please ping me in the comment box, and I'll see you in the next one. Thank you for watching this video. Thank you, guys. Thank you for watching this video, and if you really like this video, please subscribe this channel and